Welcome back. This is some conventions in chemistry, which hopefully will help you understand the work we do in class. Not only that, but help you become a bit more mindful about what you're doing and, most importantly, succeed in your tasks that you do. So we're going to have a look at naming. Elements are easy. Molecules tend to be easy as long as we remember that certain of the elements occur as diatomic or triatomic things. So in other words, two atom gases such as hydrogen, oxygen, nitrogen, chlorine, fluorine, bromine, iodine. And then we've got a triple, which we will deal with later in the course, called ozone, which is O3. So there are these combinations. Now when we find compounds, on the other hand, we find two or more elements joined together, and we tend to find there are two groups of them. If we have what's called inorganic, and to put it simply, that's basically all the compounds which have metals in them, even though there are organic compounds which bond in a particular way to metals, but that's not really in the standard level course, so we're not going to spend much time on it. So the inorganic ones are going to be the ones we use a lot in our labs, and they will normally have a metal and a non-metal component. When we do the organics, that is the carbon-based ones, and they have a whole series of rules and regulations we must obey. So they're a bit different to what we're doing, but we're going to concentrate a little bit more in this video on the inorganics. Now, in all inorganics, we always name the metal part first, and metals keep their whole name. So if aluminium is involved in the compound, then aluminium is named in the compound. We don't change the name at all for the metal component. So we simply read it off our periodic table and put it into the name. However, if it doesn't belong to the main groups, in other words, group 1 or group 2 chiefly, then it is a transition metal, and we have to let the reader know what its oxidation number is. Now, transition metals can have a variety of oxidation numbers. Many of them, like iron, have 2 oxidation states, or common oxidation states, 2 and 3. Silver has oxidation states of 1 and 2. And we should tell the reader which one we're talking about. So after the metal's name, if the metal is a transition metal, then we must put in brackets and using Roman numerals the charge on the metal ion or the oxidation state. Now, we have to look at the second part of the name. And the second part of the name can be either an element or it can be a combined group of elements called a complex ion. Now you'll note here I'm dealing with ions. That is probably what we're going to come in contact with the most, so we will develop the naming based upon that. If the element's name, if the element appears, then we simply shorten its name and add IDE. For example, if I've got NaCl, I would call it Na sodium, so I add the full name of sodium, and then chlorine becomes chloride. Alright? Now it gets tricky when we do other ones, but we simply try to make it sound right. For example, nitrogen becomes nitride, sulfur becomes sulfide, etc. So we simply shorten the name, but only if it's a single element. Right? If we have more than one element, then the name changes. If we have a lot of the compounds we're going to strike in complex ions have oxygen, a non-metal and an oxygen. So this means we have to think very, very carefully about the name. But my suggestion to you is the name will be the name of the non-metal and have a suffix. Instead of IDE, we'll have a suffix ATE, 8. So if I've got sulfur with oxygen, then it becomes sulfate, If I've got carbon with oxygen, it becomes carbonate. If I've got phosphorus with oxygen, it becomes phosphate. If I've got manganese, which is a transition metal, with oxygen, and that does exist, then it becomes manganate. So it follows through. And you'll see the other example I've given here is chlorate. So all of these things apply. So we have to remember this when our naming. But unfortunately, some of the non-metals also have more than one oxidation state. And so we must tell the reader which one we're talking about. So again, we use Roman numerals at the back. For example, we can have two different forms of nitrogen with oxygen. We can have NO3- or NO2-. Now, from our naming convention, both are called nitrates, but which one am I talking about? If I'm talking about the NO3, I would call it nitrate 5, because in this case, the oxidation state of the nitrogen is 5+. If I am talking about NO2-, then I would call it nitrate 3, because the nitrogen in this case, the oxidation state is 3. So everything we do with naming should reflect what we understand, right? So that the reader understands, and also the fact that we are using the same language that we see in textbooks, and most importantly, that we will see in test questions.